tools association with electrical technologies. So I welcome you for the session 2. So Priyanshu, you can start the session. Please go ahead.
Okay, thank you. Thank you, sir. So post-lunch session, sorry for the delay. Actually, I think it got little delayed. So we'll start the session. We had done till we had finished here till the placement stage, and we are synthesis. So after placement CTS, okay, then we had checked for the violations. We check. Let me share my screen. Sorry. So we had done till you can see my screen, right?
Yeah, you can see.
Visible? And please, yeah, thank you,
Yes,
thank you,
yes.
sir, thank you. So yeah, so we had done till the placement, and we have finished the clock tree synthesis. Okay, we had checked for the violations also. Okay, if any violation, probably like in this design, it was no violation because we had given enough period of that clock. Okay, we have not more tightened the constraints here, clock constraints particularly, so that like that timing violation should come. Okay, so if you if you give like lesser time period or lesser like for your transmitter or different signals, so that you get violation, then you have to remove those violations. So removing the violations, you can use here inbuilt ECO option and optimized design. So you can remove the violations like any stage, and here select here optimization type is setup or hold, and press OK. So it will optimize the design and it will try to remove the violations, hold violations or setup violations. Okay, whatever we want based on this option, ECO optimized design. So ECO is engineering change orders. Okay, so pre CTS, post CTS, and post route, and optimization type, setup, and hold. So any stage you can select. Okay, and optimization type, you can select anything and you can do the optimization of your design. Okay. Presently we don't have any violation in our design. So after CTS, next step is routing. So go to route and select here nano route and select route. Okay, so after routing, after the CTS, next step is routing. So select route, nano route, and route. Okay, so here you select here timing driven and SI driven. Okay, timing driven and SI driven. So SI means signal integrity issues. Also, it will take care any signal integrity issues. So and will fix the antenna issues also, and fix antenna if you select and press OK. So this is the routing done, right? Now you can see the difference between the placement and routing. This is the routing done actually. Okay. So you can save the design again if you want. Here you can save the design by selecting here save design. Okay. And you can give the design like file name as like earlier we had given GDS2.enc. So here we can give it as a routed 1, routed 2, or routed any name you can .enc. Okay, so routed 3 I'm giving, and press OK. So this design will be saved after the routing. Okay, once after the routing stage. After the routing stage, next we have to do the verification, or like you can see the DRC. Okay, after the routing we can check the DRC. Okay, so go to verify and select here verify DRC. And select here OK. So the terminal you can see if any violations are there. So verification complete, zero violation. In the terminal you can see. So it will generate a file into a current working directory. Okay, so it will generate a file into a current working directory. The file name you can see here. So this is the file name ur.drc.rpt. So you can see no DRC violations were found. Okay, so verify and verify DRC will give you the any violations are there or not. Okay, Indian design. So no DRC violations were found in this design. Next step is we'll verify the connectivity also, verify the geometry and connectivity. So next step is we'll verify the connectivity. Okay, any connectivity issues are there. Okay, so it will check for open connections, unconnected pin, unrouted net. Okay, so these many checks. So press here. Okay, so it's done. Okay, so verify connectivity. It will generate a file named as ur.cnn.rpt. So here you can see no connectivity, like no issues are there. Okay, okay, no issues are there. And then next step is parasitic extraction. So go to verify. So go to timing. Sorry, go to timing and select here extract RC. So it will generate a spef file, SPEF file. Okay, go to timing and extract RC and select here save spef. So I'm giving any other name. Okay, UR2 I'm giving dot spef and press OK. So here you can see UR2 dot spef. This is the spec file, standard parasitic exchange format or extraction format. Okay. So you can see the values here. So basically it has a spec file has your resistors, capacitors and different values. Okay. You can see here and inductors. You can see. Okay. You can see resistors, capacitors, connectivities like for the standard cell. Okay, what are the values? Okay, this is your L value, this is C value, current value. Okay, like this. So after this, after doing the parasitic doing the parasitic extraction stage or generating a spec file. Okay, so after doing the parasitic like generating a spec file, next step is your like you go to netlist and here you can give underscore netlist 4.v or any name. Okay, this is the netlist generated from the Innovas tool. This one. Okay, you can see here generated by Innovas. This is also a netlist file only. Only like some wires have been added extra here, internal wires. Okay, internal wires have been added extra, and so like you can generate an SDF file also. So go to here in timing and select here write SDF and select here active view and here select worst case. So you want 4. So like this you can generate other files also. Okay. Standard delay format. SDF file is for standard delay format. Okay. So I will search here 4.sdf. So right click open with text editor. So this is the SDF file. Okay, so this is an SDF file. Different cell times and instances. Okay, the delay values are given. Uh, Almost we have like should finish the part like of the physical design also. So now final remaining actually or saving of the okay saving of the GDS II. So any doubts are there you can ask me.
Dear participants, if you are having any more queries, you can ask them. Priyanshu, I think there is no doubt from participants. I think you can continue.
Okay, sir. So, uh, for the final step, okay, you can save the GDS2 file. Go to file and save and select here GDS oblique OSS. So either you can save the OSS file or GDS file, two file. So we'll go for the GDS2 file. Uh, Give the output file name as uart dot uart one or any name you can give. Extension should be .gds and press here OK. It has generated at the backend. So uart one. Maybe the got stuck, I think, the two. Let's save it again. Try to save it again. Press here OK. Got stuck, I think. I need to restart the tool again. So I will just restart it, like restore the design. Okay. From here, just restore the design. So how to restore the design if you want? So in the same terminal, right there, Innovus. Then here, go to File and Restore Design and select here Innovus. Restore Design file, browse. And you can select and give in routed 3. Okay. Select here Open and select here OK. So press F. And this is in select physical view, so you can see this. Okay, routed file. Then go to File, Save, GDS oblique OSS, and give the file name you want one.gds. Select here OK. So I'll see just as done or not. Okay, so it has done now. So next is you want one.gds. So this is the GDS2 file. Okay. But this GDS2 file you cannot send it to Fab because this is for only for academic purpose or academic work. Okay, the PDKs or like those the Fab labs are there. Those this GDS2 file you cannot send it because it has been designed with an academic PDK. Okay, GPDK tool. Yeah, GPDK is okay. It's not a commercial version of the PDK, the GPDKs. Okay. So any doubts?
Dear participants, if you are having any doubts related to generating the GDS2 format file, just please you can go else pre-answer. If there is no doubt, we can proceed for the next.
So after the GDS2 file generation, okay. So this is one thing. Like we have done till complete flow. Okay. So what I have done basically from morning to evening. First step, I'll just go just revisit it. Okay, we'll just revisit. Uh, so uh, so for we had done first step. So we started with the first step is design specification. Okay. Then we went through the entire design specification stage or different figures or the different uh, conditions or parameters are decided. Okay. Like in the specification stage. Then comes RTL coding. So marketing does the feedback. Is my voice audible? Hello? Is my voice audible?
Yes, Priyanshu. Audible.
Okay, thank you. Okay, sir. So first is then after doing the design specification stage, so the marketing team goes to for takes the feedback and like based on that they design the specs. Okay, then based on the specification, your RTL coding team is there. Okay, they will write the code. Okay, preferably in Verilog or VHDL. Okay, mostly Verilog is used in industries. Then next step after doing the RTL coding, next step is functional simulation. So where you simulate your test bench or test cases. Okay. For that you use NCC for Xilium tool for doing functional simulation. Then next step is synthesis. For synthesis you use Janus tool. Okay. For synthesis you use the Janus tool. So basically, synthesis is a conversion of your RTL code into gate level netlist, as it's a basic definition which everybody tells. Okay, so basically you will see the hardware out of it or the schematics of the hardware. Okay, netlist file. Then again, Modus tool is a different thing for the we use it for design for testability. So I told this is from starting, we start and this. DFT is called digital front end. From floor planning to GDS two, it's called digital back end. Okay. So floor planning, power planning, placement, CTS, routing, GDS two we had seen right now. Okay. After the lunch and we just 1 hour before the lunch. Okay. Uh, uh, so this is called as digital backend, and we had used the tool as Innovus. Okay, the tool named as Innovus by Cadence. So floor planning stage. In the floor planning stage, I told already you design your want to place the standard cells. You design which area, which place you want to place any cell or a macro. Okay, you based on the out of how much core area you want to use, the how much core utilization you want to do out of 100%, how much you want to make the utilize the core. Okay, then in power planning you do the addition of the power connections like rails and stripes, and there other things also are there. Okay, uh, so what we had seen, this is basically a 10%, 5 to 10% of the tool features. Okay. Then next step is placement. So in the placement stage, based on the floor planning, you place your cells. Okay. CTS. Also, we have seen this is placement. This is called as automatic placement and routing. There are techniques where you can manually also place the cells. Okay. So mostly the work of physical design engineer is involved there. Okay. So who are into like physical design engineer will do the like floor planning, power planning, and placement and all. They will be taking care of the design part of that the cells. Okay, physically placement, and then CTS is basically your timing engineers are there, like those who take care of the violations. Okay, so CTS like basically STA engineers are there, those who take care of the CTS and any timing related issues. Okay, so clock tree synthesis where you uh, balance the clock or balance the clock among the cells. Okay, to minimize the skew and latency and slew and any violation is there probably, so that you minimize. Then in routing stage, after CTS, next is the routing stage. So routing stage there you interconnections or the connectivity where here if it is open window, you can see this is routing we have done. So routing, after routing it will come like this. Okay. We have generated the RC file, that is your spec file basically, not RC. That is a spec where your resistors, capacitors, inductance in that. Okay. So standard delay format file, SDF file we call. Mostly SDF file is used in gate level simulation and all. Okay. So gate level simulation, they are gate level simulation engineers or those who work on these things. Okay. So those people are working on the like they simulate again the design. So and next final step was the GDS two. GDS two is graphical data stream for information interchange. Okay. So that we had just uh, exported, like it just we had just written that file GDS II file. Okay. So only the thing here. There are many things also. You can do a partitioning of a chip. Okay. So those things are there. Once you do the physical design any course, then you will see those things. Any more doubts are there regarding the tool part or something?
Dear participants, if you are having any queries related to tool also, you can ask me because nowadays so many updates are there on the cadence. So in that, so whatever the doubt is there, you can ask him. Priyansh, I think there is no more doubt from the participant, I think.
Yeah, R Ravi sir, I think, has raised an hand. Maybe you can unmute and speak, sir.
Yes, so I think participants were having any queries or just you can raise your hands actually. So you can able to unmute your microphone, you can talk. So I think we can consider as like if people don't participant don't have the any doubts from today's session, which has taken the examples of the semi-custom design of the UART from the RTL, the starting from the coding to up to the last GDS2 format. So here we have shown the flow, but this time it's won't be enough to understand everything completely without hands-on. It is very difficult to understand. So you need a lot of practice. Then only we can able to understand little bit very easily. Without having a practice, it is very difficult. I think Priyanshu, so you can take a poll, or is it over, right?
Yeah, it is over. I don't know how many people have understood this law, because usually you have doubts either if you have practiced or you have understood. If you don't have doubts, so means you don't.
Because they may, I claim they need to do practice because now only they introduce in the VTO this kind of experiments. Okay.
Sorry, sir.
So because now in VTU they might have introduced these experiments and all just now for the upcoming or the previous lab only might have introduced. Even they might have done not done that much exposure on that. So once they do hands-on, I think they will come across with the problems.
Yeah. Okay. So I don't know like how many people have understood this. So either you have like doubts if you know everything, like if you don't have doubts if you know everything, or you have not understood. So I don't know like you have understood or not. Any doubts, because your doubts have not come. So either you have understood everything, then you don't have doubts, or you have not understood anything. Because if you have practiced all, your doubts may arise.
Maybe so many participants will be beginners. So I think so. So maybe that will be the problem also. I think so.
Was it understandable, sir? Like anything not, I was able to get it like into your understandable, was I understandable with the things and all? Anything was missing from my end, so that
I think so.
that's
From
a
your
feedback
end,
just I'm asking.
yeah. So from your end, I think just you went as per the flow. Actually, it's taking a one example as a yacht. So within a shortest span of this much time, it won't be sufficient for anyone. Actually, we can't able to understand thoroughly because it is only just they are seeing what you are doing actually. Right. So once if they do by hands-on, then only they come to know everything. So maybe they may do in future, they may do by hands-on, then they'll get the problems.
Okay, okay, fine. Yeah. So whenever you are facing any issues, you can drop a mail to. I'll just drop. Can I write any in?
Yeah, just you can show your, you can type your mail ID. You can show, you can present.
Yeah, fine. Anytime if you are.
If any queries are there, even you can put in the chat session also.
You get support@ntupal.com. And so basically we are giving the support to be the like colleges and all those who are active users right now, and those who have taken the. So in that case, only we can support to the colleges. Okay, those who have already taken the cadence tool, as well as those who are active users right now. So you can drop because that actually takes a lot of. See
The
and
participants can be
uh,
get any response.
you have not taken the tools also, you can just take from us the tools. We are there for the support. Useful, or I don't know, like can you give any feedback, anyone of you, or was it understandable at least, like some part of that of the tool?
I request the participant just to give some feedbacks about the today's session. So any difficulties did you face or what are the challenges we are facing?
And will be because almost it was for one-way communication only from morning to evening. I think almost like one or two people only spoke. So,
Yeah.
maybe uh, was it understandable, or like anything really require more or something.
Okay, Pranch, I think no more questions from the participants.
Okay.
I request all the participants, please turn on your video is to take the snapshots because I'm running due to network problem. I don't able to take it. Kindly I'm requesting people to turn on your video, turn on your I request all the participants please turn your video. Yes, please turn on your webcam. Okay, thank you. Yes, Priyanshu.
Hello. Hello.
Yes,
Hello.
yes, Priyanshu.
Yes, sir.
I think there
Is
there
there
is a
like, sir, any input, sir, from your end, or can
so there
we
is a network
conclude?
issue here. I
Sir?
think yeah, you can conclude. Yeah, it's over. Yes, because there is a
Can
network issue here. Yes,
okay.
only fine. Okay.
You can conclude, right, sir?
Yes, yes, you can conclude.
Okay, okay. Thank you so much, sir. Thank you. Tomorrow's
Yeah,
session will be
okay.
taken by my manager Nagaraju, sir.
Yeah,
Tomorrow's
so
session.
thank you for today's session. Tomorrow the session will start at morning 10 a.m. So that will be done by Dr. Mamdi Nagaraju, so the technical manager from Enterprise. So just to be joined before 10 minutes of the meeting. Thank you one and all for the day one session. Feedback link will be shared in the WhatsApp group. So those who are not joined the WhatsApp, just kindly join the WhatsApp group, which is sent in the mail. Thank you.
Okay.
Thank you, Datta. So for your wonderful good sessions.
Thank you so much.
Yeah. Okay. So
Thank you.
everyone, so just you can please
Bye
you
bye.
can leave the meeting. Yeah. Yeah. Bye. Thank you.
Thank you.